In today's video, I will be explaining you the concept of force which is related to class 10. So let's begin. Whenever we'll start the concept of force, the very first question comes to our mind is what is force? As we already know that force is defined as push or pull of a body, or force is used to change the state of body from rest to motion or motion to rest. Example, if a ball is placed on a floor and you're kicking it, what happens? It's changing its state from rest to motion. And if someone is throwing a ball at you, immediately you'll catch it. What is happening over there? The body is changing its state from motion to rest. And this all actions are causing just because of the force. So here there are two examples of push or pull of a body. Example, in the first image you can see a person is trying to push the door and pull the door. And in the second image, you can see there are two monkeys and one of the monkeys is trying to push the cow and the other is trying to pull the cow. In both the cases, scenarios, we'll observe that when we are applying a force and pushing any body, it is moving away from us. And when we are applying the force and pulling a body, what happens? It moves towards us. So these all actions are taking place just because of the force. So as we have already learned about different kinds of motions in your earlier classes, so in this class we'll be just trying to learn about two types of motions, that is translatory motion and rotatory motion. So let's begin with the translatory motion. So what do you understand by the term translatory motion? Example, if you're taking a ball and you're placing it on a floor, and once you are applying the force on that ball, what happened? It moves along a straight path in the direction of force applied. I repeat, the ball moves along the straight path in the direction of force applied is known as translatory motion. Let's see the definition. So when a force is applied on a body which is at rest and it moves in a straight path along the direction of force, it is known as translatory motion. So let's see the first example. In this, the ball is placed on a floor and you are applying the force, that is push, and it is moving along a straight path in the direction of force applied. Now, in the second example, there is a toy car. Okay, once you are winding the key of the toy car and releasing on the floor, what happened? It also moves in the straight path in the direction of force applied. So this type of motion is known as translatory motion. So let us understand the concept of rotational motion. If a body is fixed or pivoted at one point and force is being applied on the body at a particular point, it rotates about the axis passing through the fixed point is known as rotational motion. Example, here is a steering wheel and it is fixed at one point. So now at whatever point you are applying the force on the steering wheel, it will move in that particular direction at the pivoted point. That is nothing but it rotates around its axis. This type of motion is known as rotational motion. So now we'll try to understand the meaning of moment of a force or turning effect or torque. So as you can see in the image, when a force is applied at the door knob, the reaction of force takes place at the hinges. So this is the point where the force is applied, and here the reaction of force is taking place, which results in the movement of the door. So this is nothing but the axis of rotation. This is called vertical axis of rotation. And here the fixed points are nothing but the hinges. So similarly, in the second image you can see the distance between the door knob and the hinges is known as perpendicular distance or moment of arm. Once you are applying the force here, the reaction of force is taking place at the axis of rotation, or you can call it as hinges, which results in the moment of force in the door. And this perpendicular distance is also known as the line of action of force. So, how much is the larger the perpendicular distance? more the perpendicular distance from the point of force. So what happened? Less force is needed and the moment of force will be more. So this is known as moment of force or turning effect or torque. So now let's understand what are the factors affecting the turning of a body. So the first factor is nothing but the force applied, in which direction the force is applied. And the second one is nothing but the distance of the line of action of the force from the axis of rotation or pivoted point. Example, you can see here, the blue color arrow indicates the force applied, the magnitude of the force applied. And the distance from the force applied and to the axis of rotation, or you can say the fixed point. So the perpendicular distance between that. Okay, perpendicular distance, and the yellowish color indicates the axis of rotation. So these two factors affect the turning of a body. The first one, magnitude of the force applied, and the second one is the perpendicular distance or the line of action of force from the axis of rotation. So let us understand the definition of moment of a force or turning effect or torque. The moment of a force or torque is equal to the product of the magnitude of the force and the perpendicular distance of the line of action of force from the axis of rotation. Now you know the meaning of magnitude of the force, that is force applied, and perpendicular distance is nothing but distance from the point of force to the axis of rotation, that is pivoted point. So what is the expression for this one is, expression of moment of force is moment of force is equals to force into perpendicular distance of the line of force from the pivot. So now let's learn units of moment of force in different systems. So first one, SI unit, it is Newton meter. In CGS unit, dyne centimeter. And in gravitational units, SI unit, it is kilogram force meter, and CGS unit, it is gram force centimeter. Now moment of force values in different units are as follows. First one, 1 Newton meter equal to 10 power 7 dyne centimeter, 1 kilogram force meter equal to 9.8 Newton meter, 1 gram force centimeter is equals to 980 dyne centimeter.